Welcome to our channel, where we bring you the most interesting and informative content from around the world. Look up at the night sky, far from city lights. What do you see? Thousands of stars, like tiny diamonds scattered on black velvet. Each star is a sun, some smaller, some larger than our own. But they are not scattered randomly. They are grouped together in vast, swirling collections called galaxies. Our own galaxy, the Milky Way, contains hundreds of billions of stars, and it's just one of trillions of galaxies in the observable universe. Understanding galaxies is crucial to understanding the universe itself. Join me now on a journey through time and space, as we explore the fascinating world of galaxies. To understand the origin of galaxies, we must rewind the cosmic clock to the very beginning, the Big Bang. Roughly 13.8 billion years ago, our universe burst forth from an extremely hot, dense state, expanding and cooling over time. In the universe's infancy, there were no stars, no galaxies, only a seething cauldron of elementary particles and radiation. As the universe expanded and cooled, protons and neutrons combined to form the first atoms, primarily hydrogen and helium. This early universe was not perfectly smooth. Tiny quantum fluctuations, present at the moment of the Big Bang, created regions of slightly higher density. These density fluctuations, amplified by gravity over millions of years, would serve as the seeds for the future formation of galaxies. As gravity drew matter together within the overdense regions, vast clouds of primarily hydrogen and helium gas began to collapse. These clouds, called protogalactic clouds, were the progenitors of galaxies. As a protogalactic cloud contracted under its own gravity, it began to spin faster and faster, much like a spinning figure skater pulling in their arms. This rotation flattened the cloud into a disc-like structure, with a denser bulge forming at the center. These were the first stars, blazing giants that illuminated the early universe. These explosions enriched the surrounding gas, with heavier elements, setting the stage for the next generation of stars. Gravity continued to play a dominant role in shaping the evolution of galaxies. Galaxies are not static, unchanging islands in space. They are dynamic systems, constantly in motion under the influence of gravity. Stars within a galaxy orbit around the galactic center, their paths shaped by the combined gravitational pull of all the matter in the galaxy. Spiral galaxies, like our own Milky Way, have a central bulge and graceful spiral arms, where star formation is actively taking place. Elliptical galaxies are smoother and more rounded, with less gas and dust and older stellar populations. Galaxies are clumped together in clusters and superclusters, interconnected by filaments of gas and galaxies, forming a vast cosmic web. Section 5: Star Birth and Death, the Engines of Galactic Evolution. Stars are the fundamental building blocks of galaxies, and their life cycle plays a crucial role in the ongoing process of galactic evolution. Stars form within dense clouds of gas and dust, known as molecular clouds. Here, gravity overcomes the outward pressure of gas, causing the cloud to collapse under its own weight. As the cloud collapses, it fragments into smaller clumps, each of which can potentially form a star. This process is both intricate and fascinating, leading to the birth of new stars. Massive stars live fast and die young, exhausting their nuclear fuel quickly and ending their lives in spectacular supernova explosions. These supernova explosions are incredibly powerful, releasing vast amounts of energy and enriching the surrounding interstellar medium with heavier elements, essential for the formation of new stars and planets. Our own Sun and Solar System formed from the remnants of previous generations of stars, enriched with the elements necessary for life to arise. This cosmic recycling process is fundamental to the evolution of galaxies and the universe as a whole. Section 6: Galactic Collisions, a Dance of Titans. Galaxies are not isolated islands in space, they are engaged in a constant cosmic dance, their movements influenced by the gravitational pull of their neighbors. Occasionally, this dance leads to a spectacular collision. When galaxies collide, they don't simply smash into each other like billiard balls. Instead, their gravitational fields interact, distorting their shapes and triggering bursts of star formation as gas clouds are compressed. These collisions can be incredibly energetic, lasting for millions or even billions of years. Stars themselves are unlikely to collide directly due to the vast distances between them. Our own Milky Way galaxy is on a collision course with our nearest large neighbor, the Andromeda Galaxy. Section 7. Dark Matter, the unseen hand guiding galactic destiny. While we can observe stars, gas, and dust in galaxies, there is a mysterious component that dominates their mass: dark matter. This enigmatic substance makes up about 27% of the universe. Dark matter doesn't interact with light, making it invisible to telescopes, but its gravitational influence is profound. It bends light from distant stars and galaxies, a phenomenon known as gravitational lensing. The existence of dark matter is inferred from its gravitational effects on visible matter. Without it, galaxies would fly apart. Galaxies rotate much faster than they should based on the visible matter alone, suggesting that a halo of unseen matter must be providing the extra gravity to hold them together. This unseen matter is dark matter. Dark matter plays a crucial role in galaxy formation and evolution. It acts as a cosmic scaffold, guiding the formation of structures in the universe. The gravitational pull of dark matter halos is thought to have drawn in the gas that formed the first stars and galaxies. Without dark matter, the universe would look very different. Unraveling the mystery of dark matter is one of the most significant challenges in modern astrophysics. Scientists around the world are working tirelessly to understand this invisible force that shapes our universe. Section 8. Types of galaxies, a diverse cosmic zoo. Galaxies come in a wide variety of shapes and sizes, each with its own unique history and properties. Astronomers classify galaxies into different types based on their morphology, or appearance. Spiral galaxies, like our own Milky Way, are characterized by their graceful spiral arms, a central bulge, and a surrounding halo of stars and dark matter. Elliptical galaxies are smoother and more rounded than spiral galaxies, with less gas and dust and older stellar populations. Irregular galaxies lack a defined shape, often the result of gravitational interactions with other galaxies or internal processes like starbursts. This diversity of galactic types reflects the complex interplay of gravity, star formation, and galactic interactions that have shaped the universe over billions of years. Section 9. Active galactic nuclei, the hearts of darkness. At the center of many galaxies, lurking within the central supermassive black hole, lies a region of intense activity known as an active galactic nucleus, or AGN. These AGN are among the most luminous and energetic objects in the universe. As matter falls into the supermassive black hole at the center of an AGN, it forms an accretion disk, a swirling disk of gas and dust heated to millions of degrees. AGN can be incredibly powerful, outshining the combined light of all the stars in their host galaxy. The study of AGN provides insights into the physics of black holes, the processes that drive galaxy evolution, and the nature of the early universe. Section 10. The future of galaxies, fading giants and new beginnings. As we look to the future, the evolution of galaxies will continue to be shaped by the intricate interplay of gravity, star formation, and galactic interactions. These forces have been at work for billions of years, sculpting the universe into the magnificent tapestry we observe today. However, the universe is also expanding and cooling, which will have profound consequences for galaxy evolution. This expansion means that galaxies are moving further apart, and the cooling universe will affect the processes that drive star formation and galactic dynamics. As the universe expands, the gas clouds that fuel star formation will become more diffuse, making it increasingly difficult for new stars to form. These gas clouds, once dense and vibrant with activity, will spread out, leading to fewer regions where new stars can be born. Over time, galaxies will gradually run out of the necessary fuel, and star formation will cease. This will result in galaxies that are populated primarily by older stars, with fewer bright, young stars to light up the cosmos. Existing stars will continue to evolve, with low-mass stars like our Sun eventually ending their lives as white dwarfs, slowly cooling over trillions of years. These remnants will be the final stages of stellar evolution, marking the end of an era for many stars. Galactic mergers will continue to play a significant role in shaping the universe, with smaller galaxies merging to form larger ones. These cosmic collisions will create new structures and potentially trigger bursts of star formation in the newly formed galaxies. The universe of the distant future will be a very different place from the one we observe today, dominated by fading giants and a slowly dimming cosmic background. The once vibrant and dynamic universe will become a quieter, more subdued place, as the last remnants of star formation fade away. Section 11, Conclusion: Our place in the grand cosmic ballet. Our journey through the realm of galaxies has taken us from the fiery birth of the universe to the fading giants of the distant future. We have witnessed the awe-inspiring power of gravity, the elegant dance of galactic interactions, and the life cycles of stars. Galaxies are not merely distant objects in the night sky, they are vast, interconnected systems that have shaped the universe we observe today. We are all products of this grand cosmic ballet, our very existence intertwined with the life cycles of stars and galaxies.